All right, today we are going to be just taking a brief look at square roots and powers, or powers and square roots. And you'll understand a little bit more about that as we go. Again, it's not going to be real in-depth. We'll get to a more in-depth application in our next lesson with the Pythagorean theorem. Whatever that is, you'll find out next time, if you don't know already. Anyway, let's just get into powers and square roots. That was a good one. All right, over here we have some examples to do when we're getting into some letters here, and then we have some weird looking things over here that we'll break down and take a look at what those mean. Well, when people say power, like to the second power, third power, typically what people mean is the numerical value placed in the small number here, the exponent. So when they say power, this would be to the second power, to the third power, fifth power, sixth power. It can go on and on. But the second power and the third power, they have special names. If it's to the second power, people typically talk about that as something being squared. It's supposed to be an S. Squared. Something squared. That means times its own self 2 times. I'll break this down for you here in just a little bit. When something is to the third power, people talk about that as being cubed. 4 cubed, or times its own self 3 times. So as we look at this, the answer is not 10. It is not 10. You do not multiply this number times this number or this number times this number. That's not what that means. The little number tells the big number what to do. Think about somebody who might be a 5-foot-tall basketball coach. My guess he's going to be doing a lot of coaching like this. Right? But the little one is telling the big one what to do, where to go, how to act, that kind of thing. Same thing's happening up here. We have the little number telling the big number what to do. Apparently the coach is on a big ladder or something. But the little one's telling the big one what to do. So this one says, take yourself, number 5, times your own self, the numerical value that I have. And I have a 2. I'm a 2, so I'm telling you to take yourself times your own self, multiply it yourself twice. So that would be 5 once times 5 twice, and that would actually be 25. Again, the little one tells the big one, what to do by multiplying its own self by the value of this number. If I was a 7 and I was telling a number 3, hey, 3, multiply yourself times yourself 7 times. Then it wouldn't be 3 times 7, it would be 3 times 3 times 3 times 3, and so on. So that's what the power means, or the exponent, the little number means. 3 times 4, again, is not 12. And people will do this all the time until it gets to be kind of automatic, so don't feel bad if you blow it. People blow it all the time. The trick is just continuing on, though you blow it, until it becomes automatic. No big deal there. 3 times 4 would be 4 3 times, which would be 12. That's wrong. 3 is telling the 4, take your own self times your own self 3 times. So we have 4 once, 4 twice, 4 3 times. So it's not 4 times 3 is 12. We got 4 times 4 is 16. 16 times 4 is 64. So it's way different than 12. 12 is way different than this. So it does make a big difference depending on your number and your power. This is the power. That's called the base. And then there's some other terms for it depending on whatever math you get. Some might call it something else, but we'll get into that later. So we have the exponent telling that one how many times its own self. So now we can do it backwards. Well, what would 2 times 2 times 2 be? Well, don't think, well, 2 times 3, 6. 2 times 2 is 8. 8 times 2 is 16. But 16, if we're going to write it in with an exponent, we have a number 2. We have the base here, 2. How many 2's do we have? Well, we have 1, 2, 3. So we have 3 of those, 2 cubed. 2 times 2 is, it's 4. 4 times 2 is 8. See what happens when you start doing stuff in your head? So this is 8. See, talking it through helps. The more you do in your head, the more you get behind. So 2 times 2 is 4. 4 times 2 is 8. And 8 is the same thing as 2 to the third power, or 2 cubed. So it goes both ways, whether we're starting here, going there, or starting here, going there. We can do that. And we can even just skip the 8 and just go 2 cubed. And then figure that out as 8 if we're solving for that. Then down here we have letters. We have y's. Why? Because. I know that was stupid, but we have 2 y's. So we have y, whatever that number would be, like here was the big number was a 2, big number was a 4, the big letter is a y. So how many y's do we have? We have 1 y, 2 y's, so we have y to the second power, or y squared. It works the same with letters, works the same with numbers. It doesn't even matter. Whichever one it is, it works. The principle is the same. So the higher you go in math, the more things you're going to have here. You're going to have x's, you're going to have symbols that go on, but it's the principle that's the same. That's the power. All right, so that's power. Squared for the 2, cubed for the 3. Little one tells the big one how many times to multiply itself by its own self. So let's get over here to this thing. This is called a radical. Some people make their division symbol like that, like 4 divided by 2. Now would be a good time to stop that, because now it means something completely different. Yes, it's more fancy and kind of nifty to put that little extra line on there in division, but now it means something completely different. Now it means what number times its own self equals the thing in the box. So we have 25. We have what times its own self equals the thing in the box. Does 2? 2 times its own self would be 4. So it can't be 2. It's what times its own self equals the thing in the box. Well, in this case it's 5. 5 times 5, its own self, equals a thing in the box. 5 times its own self equals a thing in the box. Okay? So what times its own self equals this? You may or may not know this. This is one that comes up a lot. But in this case it's 12. 12 times its own self, 12, equals a thing in the box. Another way you might write this is if 5 times its own self equals the thing in the box, we might be able to break that down into what we know about this. We know 5 will divide into that. We know, actually that's about it for 25 and 25. So we can start looking at the number patterns and try and kind of see if you don't know. And your teacher will get into either prime factorization or some other way of doing that. And there's a bunch of different ways, and I don't want to take the time now to get all complicated for something that your teacher may have you doing some other way. But just get the idea that the radical, the square root sign, means what times its own self twice. 5 times 5 equals a thing in the box. So if we go here, what times its own self equals 16? Well, 2 times 8, so it's 8. 8 times 2, right? It's not 8 times 2, 8 times its own self twice. No. What times its own self? So this would be 4 times 4 is 16. So the answer is 4. 4 times its own self equals the thing in the box. And I know I've said this a dozen times, but people get kind of confused sometimes. Square root of 3, square root of 3. See, I just jumped ahead. See how easy that is? So the square root of 9, what times its own self equals 9? 3 does. 3 times 3 equals 9. So there you go. Because you have 3 squared equals 9. 3 times its own self twice equals 9. That's why it's 3. Here, 4 times 4, which equals 4 squared. Or 4 times its own self twice. That's why it's 4. And so on. This is 5 times 5, or 5 squared equals just the thing in the box. So it's 5. Hopefully this makes sense to you. It's not a hard concept, but it's difficult when it's new. When people start using new words like square root or radical or power or squared or cubed, all those new words can kind of get in a mess in your head. But just get the idea that the little one tells the big one what to do, how many times to multiply itself by itself. And then the square root sign here just means, and sometimes they'll put a little thing like this on it too, depending on what editor your book and your printer is. But it means the same thing. What times its own self equals a thing in the box. Anyway, that's powers and square roots. Have fun with this. Practice. You'll get it. No problem.